Now let's do an applied question. Consider two children fighting over remote control. Daniel exerts a force of 40 newtons and Anna applies a force of 50 newtons, and they apply these forces as shown in the diagram. Determine the direction the remote control will move and the force in that direction, so the resultant force. Now we will do more of these later, but just to start off. Okay, so let's put our origin in the middle. So there's O. So writing Anna's vector in Cartesian forms, nice and easy. Let it be the vector A. That is just going to be 50i because there's no y component. For Daniel, we can make our triangle and we need to find our y and our x. So remembering x is equal to r cos theta. In this case it's going to be negative. Our theta is 180 minus 150, which is 30 degrees. So that's going to be equal to negative 40 cos 30. As an exact value, that's 40 times by square root of 3 over 2, which is negative 20 root 3. Our y is r sine 30, or r sine theta. It is positive, so 40 sine 30, exact value 40 times a half, which is 20. So that means my b vector is negative 20 root 3i plus 20j. Now our resultant force is going to be A plus B. I'm going to draw a diagram to show why. This is Anna there, vector A. What we need to do is draw Daniel on the end of that. So B, vector B. Now our remote is going to go in that direction there. So it's A plus B. So that's 50i plus negative 20 root 3i plus 20j, which is approximately 15.36i plus 20j. The magnitude of the force is going to be the square root of 15.36 squared plus 20 squared, which is approximately 25.22 newtons. Our direction is going to be that theta there is going to be inverse tan of y over x. So 20 over 15.36, which is approximately 52.48 degrees. Therefore, remote will move with an approximate force of 25.22 newtons at approximately 52.48 degrees. Now I'm going to show you that sometimes there are other options that are quicker. So if this is 50 newtons and this is 40 newtons and our angle in between is 30 degrees, and we know that because this is 150 degrees, we can use trig with our cosine rule, because you have that vector, the angle in between, and you're trying to find the resultant. So you can go a squared equals b squared plus c squared minus 2bc cos a, plug in your information, which is approximately 635.90. So a is approximately 25.22 newtons, which agrees with what we had. And for our angle, we still need that theta, and for that we can use our sine rule. So opposite, opposite. So we can go sine theta over 40 equals sine 30 over our r, 25.22, times both sides by 40. Sine theta is approximately 0.79. Theta is approximately inverse sine of 0.79, which is approximately 52.48 degrees. And you can see that those answers match up. So two different ways to solve exactly the same problem. One thing that this does stress, this example, don't just always think it's b minus a. Sometimes it helps to draw a diagram. In this one we realized our resultant force was a plus b.